66%. No, I'm confident in its ability to not really sell a lot, so I'm okay with 25%.
No, put like an outrageous amount on it, somebody will buy it.
Yeah, I know, that's funny. It's true, though.
Just to try it out.
Yeah, it's true. Back in the early days of the App Store, especially, people would see something for like $80 or something, they'd be like, "Oh, it's got to be good," and they'd buy it and just be just garbage, you know. Back in like the 2008, 2009 period.
So you get like one buy off of it, and then the review's like, "This is horrible, don't buy."
Yeah. All right, so tonight, so start up Xcode, and we will create a new Xcode project.
Don't tell me, that's a game one.
It is a game one. How did you know? It is a game one, so for your template, make sure you select game, not the single view.
We need to integrate gameplay kit.
What's that?
There's an integrate gameplay kit option.
Integrate gameplay.
On the next screen.
Oh.
On the one of
Oh yeah. No, we won't integrate gameplay kit.
Okay. What do we
Let's see. Let's call this. We're gonna call it Pong.
Yeah. Isn't there like a copyright? Yeah.
Well, we won't worry about that until it actually becomes an issue. I'm probably not going to actually. I could put this out in the store and not release it. So, I mean, if you really want to release it, we can. In that case, maybe we'll call it Ping Pong. Actually, I don't think there is a copyright because there's lots of like Candy Crush knockoffs. Yeah, but the name itself probably. Yeah, we'll just call it Ping Pong. All right. As far as the game technology, this will be SpriteKit, not SceneKit. So differences, SpriteKit, as the name implies, you're working with sprites, and the sprite nodes are the basis of it. SceneKit is more animation based on a scene. OpenGL is hardcore, like low-level graphics language calls. And then Metal is a new kit, which I haven't really had much experience with. It's more of a 3D modeling thing. So for what we're doing with Pong, we don't really need that. So we're going to go with SpriteKit. And next. And do not create a Git repository. And it's just sitting there. Here we go. Voila.
I like my privacy.
Well, yeah, especially since we don't want anyone hearing this. I mean,
especially when we talk about bulkers.
Yeah. Plus, someone could steal this confidential information, even though I'm publishing it on YouTube, nonetheless.
Isn't it password protected?
Yeah. We could make this, online game, and then you have to log in to play. Keeps track of high score, that kind of thing. Okay, so a few things about a game as opposed to a regular app. So let me change my simulator. App delegate, everything. Whoa, hey, that's right, everything's huge. App delegate, everything is pretty much normal. There's not much different in the app delegate class. It's all boilerplate stuff. But now you'll notice, like, let's go into the game view controller. Instead of just view controller, it's game view controller. Still derived from UI view controller. But there's some differences. So instead of having, we still have a self.view, but it's not a UI view. It's a SceneKit view, an SK view. And with the SK view, you create a SK scene, and the SK scene is basically the canvas upon which you paint your game. So the SK scene is the main thing that you work with. It has a few settings here, like this. The guy shows frames per second, so you'll notice that's a built-in thing. You notice when we first build this, it'll be displaying the frames per second count. So game scenes are built on the concept of, it's kind of like almost like a video. You're showing frames. Node count is the number of nodes that are getting created. And then you have device orientation support there, which used to be built into the UI view stuff too, but it no longer is. So yeah, that's the difference with the view controller. Then you also notice there's a game scene.swift file. This guy is what we're going to be working with primarily. This is the SK scene. So when you see in the view controller where it created the SK scene, that's this guy. So this corresponds to the view, regular UI view, and this is its counterpart in the game world, in the Sprite game world. And it's got a ton of boilerplate code here. We're going to remove all this stuff because we're going to write our own stuff. This is just like basic stuff to give you a little animation. So if you go ahead and run this guy, you can go ahead and build it and run it. This might take even longer to load. So it's probably a good idea to get it up and going. The other thing is, if once we get this built and get it working, I would encourage you to run it on a device if you have one, because the difference with a game, difference with a regular app isn't real significant usually, but the difference with a game is the physics motion on a simulator is not nearly as close as a real device, which I noticed once I built this, because I did a concept app and played with it on the simulator and then ran it on my phone, and it was like night and day.
Hello world.
Yeah. It says hello world. If you tap with the mouse, if you click and drag, it'll create a series of geometric shapes, I think.
I'm jealous.
My son came home, showed me a water bottle, and he was like, I love it. He is obsessed with this Five Nights at Freddy's.
Oh yeah?
Do you know what it is?
No.
It's a computer game. It's got, do you know what it is?
Of course he does. He's
Animatronics,
like 17.
like,
Yeah.
similar to like what Chuck E. Cheese has. Like
Okay.
those characters.
Yeah.
But it's like a creepy version.
Oh, nice.
And so they do like jump scares where they pop out and scare you when you watch it. And I don't know. I don't really know how to play the game. He watches it on YouTube. They have a guy on there called Purple Guy. So he likes.
How old is your son?
Purple.
I thought I got the oh, that's right.
Okay, got the pink one.
How old's your son?
7.
Okay.
Yeah, he's probably a little young for Five Nights at Freddy's, but
Life before.
Oh yeah. That's nothing. My wife teaches 4K in Wisconsin Rapids, and she's telling me about one of her 4K kids wore in a T-shirt, a slip, like 4-year-old friendly. Yeah.
no, the parent probably loves them, and they
Yep.
went to like.
The thing is though, the other 4-year-olds probably don't get it.
They don't know it.
They don't know, so it really doesn't matter.
No, to them, no, but to the 4-year-old that's wearing a T-shirt, like he watches the videos and stuff. I mean, if you've ever seen one of their videos, I mean, that's some scary stuff. But that's okay. I mean, he's being conditioned at a young age. All right. Wow, this is just painfully slow. It's getting there. It's getting there.
I was waiting.
Yay, finally. All right. So it'll create this like slinky sort of thing when you tap and drag with it, which is pretty cool. Actually, let's just release this. All right. Yay. Okay. So some other stuff I want to point out. Some similarities and some differences. So instead of having a view did load, you have a did move to view.
Who named it Spiny Node?
I don't know. The spinning node, you mean? Spiny node.
What's the difference?
Between a spiny node and a spinning node? One implies action, the other implies its shape. All right, so we got to touches move, touches in, all the normal stuff that you have in a UI view. That stuff all exists. So what we're going to do is we're going to get rid of most of this. Keep the did move to view. You can get rid of the spiny node and the label. Delete those guys. So there'll be some errors popping up, but we'll take care of that. Get rid of everything inside the did move to view. You don't need that. We're going to create our own stuff. The stuff down here, that all goes away. And let's see, touchdown. Like all these functions we no longer need. All we're going to be left with is going to be the did move to view and then the update.
That's it.
For now.
That took care of all my errors.
Yeah, so the did move to view, like you say, is kind of the equivalent of view did load. It allows you to initialize your scene. And then the update happens every time a frame is refreshed. So at the beginning of every new frame, this guy gets called. There, so now I got an empty scene, which is exactly what I want. Now the other thing that's different is you have a couple of other files. Here's action.sks. This actually is like a recording that you can create that's an action. So an action is when an object moves across the screen. That's an action. And then the game scene.sks, open that guy up. This is kind of like the equivalent of a zip file, the SKS file, the scene. I'm going to zoom out. So if you click on the minus sign, that'll allow you to zoom out so you can see it a little bit better. Yeah. So let's delete the hello world label. And that's as far as I can zoom out.
Just the little cross stay there.
Yeah, the little cross is just, that's just an indicator to the center point of the view. Another thing that's different about a scene kit or a game as opposed to a regular app is that in a regular app, your 0 point is upper left-hand corner, and as you go right, you go positive in the X, and as you go down, you go positive in the Y. With a game, it's the opposite. Your center point is actually dead center of the screen, and everything up that's a negative Y. No, that's a positive Y, I'm sorry, and everything down is a negative Y. So it's kind of really different when you go from regular, if you're doing any type of graphic stuff in a regular game, or I mean a regular app, and you go to a game, it's really different. All right, so here also on the library over here, we got some different objects than what you're used to seeing. The label's one of the few that's the same, but otherwise you don't have view controllers. You have a lot of like physics stuff, a lot of vector stuff, so a lot of more like gamey kinds of things.
A turbulence field.
Yeah, isn't that cool? So a few years back, I actually made like a Space Invaders game, and they didn't have a turbulence field back then. But I think because of suggestions from developers who were actually writing like that kind of game, they created that. But yeah, so for my game, I had to actually kind of like manually simulate turbulence where you're going bouncing up and down and stuff. So yeah, they've added a lot of new stuff. The emitter object is pretty cool. Like you can emit sparks and you can emit all kinds of like flames and stuff. All right, so the first thing we're going to start off with for our game is a color sprite. we'll drag this guy over onto our scene here. And when you drop it, it should turn red. It will have like a little, the line, the circle in the center and the line is like the orientation point that allows you to set which way it's going to, if you had something that wasn't a circle, something that had a non-symmetrical shape, you can point it in a certain direction with that. Okay, so up here, where the little ruler thing normally would be, that's your properties inspector. So this guy will be our paddle. So you want to change the color on it to be white. Now here's you notice that the positioning on here is pretty granular. This is actually a floating point as opposed to an integer value. And it goes out 3 decimals, so you got a lot of precision when you're working with a game. X is negative, so it's a little bit left to center, and Y is negative 531. So on a normal view, this would be like a positive 700 or something like that. So what we're going to do is we're going to set the position of it using these position coordinates. I'm going to set it to like a negative 550 in the Y, and then 0 in the X. So this will be our first paddle. And then for size, let's set the width on the paddle to be, what's it, 100 right now, maybe 200. You can always adjust these too to make it harder. Height will make like 30. There, that kind of look like a paddle, yeah. All right, so then the next thing we want to do, you can add a texture. Like when we create the ball, we'll actually use a texture. For this, we're just going to use the color sprite. We're just going to set it to the white because, I mean, that's all Pong really is. For the name,
So position, you have
I just have 0 and 0.
and then Z you have left.
Yeah, Z is 0. We don't have any elevation. Rotation is 0. Width is I have set to 200, and height I have set to 30. Anchor point you don't really need to worry about.
Why did that put mine up at the, if you have Y position is mine?
It's got to be negative 550.
Thank you. You said 0, the Y. Y.
X is 0, Y is negative 550. Because center point is right, so if you set Y to 0, it should actually be right in the middle.
That's what it did.
Yeah. Okay, so name of it. So this is, you give it a name that's kind of like an identifier, kind of like a storyboard ID that'll allow you to reference it in code. So we'll call this, this is almost, not really, but kind of like creating an outlet. We will call this you, as in yourself. And then we'll create another one of these, but I want to get these various factors set first.
So U as in YOU?
Yeah. All right, so now down here, if you scroll down, so you get past the position stuff and scale and all that, down near the bottom there's a physics definition. We'll want to change that, the body type, from a none to a bounding rectangle. And then when you do that, a bunch of other properties pop up. So what that does is that establishes physics around the object so that it will have characteristics such as friction, gravity, rotation, that kind of stuff. We want this to be basically a solid object that does not have any deformation. The ball, when we create the ball will have be able to deform and rebound and stuff. We want that to be bouncy, but this guy we don't. So what we're going to do is, for these characteristics, I think, if I remember right, the best settings was just to remove a lot of it. I think I set these guys, we turn these off, allows rotation we don't want, and we don't want affected by gravity. So if it had affected by gravity, it has a mass here. So if we turn that on and allowed gravity to take hold, it would just like drop off the screen. It just like, it just dropped. So you don't want that. Friction will be 0.
Did you take dynamic off too?
Yep. Restitution is 0. Linear dampening and angular dampening. So we'll try that what they have here. So what that refers to is as you move it around on the screen, it will have like a slowing, a deceleration kind of effect to it. Initial velocity we're going to set in code, so we'll leave that alone. Category mask refers to what category of object it is. We'll set this to 1. So that's kind of like an identifier that is internal to the game. So like the game knows that this guy's got a category mask of 1. So it deals with the interaction of the objects. If we have, for example, with the ball will set to have a category mask of 2. And then we'll establish a rule that says if category mask 2 interacts with category mask 1, then you have a collision. And that's what this collision mask is. This guy will be our ball, so this is going to reference the ball. This is 2. Field mask is 0. That's something we're not going to use. Contact mask will be 2 also. Okay, so that creates basically the physics body that we need for our paddle. Now that we have that guy created, we can make a copy of it. So you can do the selection and then alt drag just like you would normally. And place that guy up at the top, and this will be our opponent. And this is set to you. That's also set to you. Now let's name this one them. The parent, by the way, just refers to the scene, SK scene 0. So you can have more than one scene, just like you can have more than one zip file. So with the Y, we'll make that negative, or we'll make that positive 550 rather. X is 0, rotation 0, height, okay, all that's good. Color white, all that's good, good, good. Basically, the settings on this for, I'm going to turn the friction off here. Friction, so like if you have a friction coefficient, that when an object makes contact with it, it'll kind of like stick, so we don't want that either. I thought I had those set on the other one, maybe I didn't. Yeah, they're just set on the other one. All right, mask can be set to that, that's fine. Category mask will still be 1 because this guy, what that says is this category and the other category, those are the ones we worry about. So the category mask, since these aren't ever going to interact with each other, they can have the same category mask, and that means that they'll interact with category 2 the same way. Field mask 0, so that's all good. Those are exactly the same settings, that's fine. Save that. And then the last thing we need to do is create a ball. So that's bounding rectangle. Okay, that's good. All right, so now we'll create the ball. So you take another color sprite, drag it out, plop it down about the center of the scene. And for this guy, let's make the size, first of all, we'll call this the ball. Texture we have to set. We're gonna do that.
Spaceship,
Spaceship.
that's the option texture.
Oh yeah, you can. I mean, that's one of the options. But we're gonna actually set our own texture for this guy. It creates a spaceship. All the texture really refers to is just an image that you're applying to it.
That's a cool spaceship.
Yeah, it's more like a jet to me, but
Yeah, but jets can fly in space.
not really.
They could. There's nothing stopping.
Yeah, lack of oxygen. Because the jet engine, a rocket engine can fly in space. A jet engine can't.
Right.
Yeah.
But I'm saying the actual plane itself
Mm-hmm.
could
If it was propelled by a rocket, yeah, it
go
could.
through space.
Right. All right, so position is going to be 0 in the X and 0 in the Y. Size width will be 30 height will be 30.
Small ball.
Yeah. Well, you'll see. You know, if depending on how fast, you know, we'll have various factors we can set that'll make it go faster and stuff. Color will be, we can just set it to white for now. Alpha 1, all right, that's all good. Body type, down here in the physics definition, this will be a bounding circle, since it's a circular shape. This stuff we will take off as well. We're not going to have it affected by gravity. We are going to give it a force vector, but we're not going to give it a gravity because we don't want it. In the real Pong game, it doesn't, you know, it doesn't have gravity. It doesn't like go up and then like fall back down. Friction for the ball. Let's see. I had some variables I set for that. Actually, I think this guy does need to be dynamic too for the ball. Turn the dynamic on. Friction is 0, but the restitution, set that to 1. Linear dampening will be 0. I think I played around with linear dampening and it just didn't work real well. Mass is smaller because it's a smaller object. Okay, so category mass. Now this is where we set this guy to 2, whereas the paddles are each 1. Collision mask now is going to be the paddles, so that's 1. So now you can see why we set 1 for both the paddles, because now the same rules apply to the ball for each of these. Its collision mask is a 1. Field mask is 0. And contact mask is also 1. All right.
How does it know not to go off the screen?
We will set that. That's something we have to actually add. That's a good question. So we're going to create a bounding frame upon which it'll bounce off of that as well. All right. So now we have that, but we need to actually set our physics body or our shape for that. So let's go out on the internet, our friend Mr. World Wide Web. And let's do an image search for a ping pong ball. I'm gonna grab one that just has a white background because then it's easy to set it so you have a clear background. So if you find one that has a white background or a clear, go ahead and copy that. Copy this image. If you go up to Spotlight Search and just look for preview, then you can do in preview, whenever it starts up, you can just paste from the pasteboard and create a new image. Hello preview, where are you? All right. So in preview, you can just do File, New from Clipboard, and that'll paste the ping pong ball into a new image. You guys all have a ping pong ball?
I have one saved, but it's not. My preview's taking a minute to load.
Yeah, I don't know why. For some reason, preview is really slow on these machines.
You have preview in like the top left, and your file, and then I didn't know it was in this.
No, we can load that.
It was in file. I did
You
copy.
saved it?
All I did is I copied the image and then I pasted it into preview as a new image. Like Isaiah was saying, if you do File, New from Clipboard, that creates a new image. And I'm not going to save it just yet because we got to do some manipulation to it.
You did take notes.
I noticed that this is off of Amazon.com. They're advertising Brewski Brothers Beer Pong. So I thought that'd actually be a good game to create a virtual, like a mobile app Pong game. So you don't need a table and and the actual ping pong ball and stuff. You can still have the beer, but you just do like a virtual game where you're playing against someone else. So I thought, oh, that's a great idea. So then I went out and I searched in the App Store for it, and there's like 3 or 4 already out there. It's like, oh.
No chasing balls.
Yeah. So anyway, now that you have it in preview, if you click on the toolbox guy, that brings up some handy dandy features. One of them is the little wizard wand. This will allow you to select areas of the picture and set them to clear or remove them, so you can create a transparency. So I'm going to make sure I select up to my ball. I don't want to actually, because you could just delete everything, but it should highlight with the little marching ants thing around it, and then I hit delete, and then that removes the background, so all I have is the actual ball itself.
Yeah, I think I did something.
If your image is gone, then you did. Command Z will take you back to where you were.
It
How do I do
blocks my ball too.
How do I drag around?
This is
Draw around. Sure. Yeah.
Okay.
Oh,
I have
is
my
there a way
ball.
to do that on?
I like your ball.
Thanks.
That's what. Never mind. All right, so now that we have, I didn't finish that. I'm sure that if Adam were here, he would have. But now that we have it there, this is a little large. What I'm going to do is up in the Tools menu, there's an Adjust Size. So this mine's set to 300 by 300. Ideally, set yours to 60 by 60 pixels. And click OK.
Mine doesn't do that because it's 60 by 30 and it.
Oh, yeah, that's another thing. You're going to want it to be symmetrical. So you want a nice square.
Is yours?
Yes.
I'll go grab yours.
How did you find a ball that's...
It looks normal.
You probably have a lot of white space around it. Yeah, 60 by 60 will create a really nice effect that doesn't get pixelated.
Now we can save it.
Yeah, now go ahead and save it. Save it, ideally save it like in your application folder somewhere. It's not critical, but that's the easiest way to do it. Ping pong.
Save as.
I'm just going to save it as ball. Make sure that the type, the format is set to PNG. And alpha is checked, and then just click save.
Alpha is checked.
Yeah, set alpha to on.
I don't have a save as option in my preview.
There's a box near the
Where
bottom.
did you save it?
I saved it in my project folder. Down near the bottom, there's a format that you can specify what format you want it saved in.
Mine is PNG, but I don't know. Like I don't have a save as. Like
No. That's what I meant by save as is the file format. So set it to PNG as long as you got that.
no, I mean I don't have anything for that to pop up because mine is already saved to my desktop.
Well, as long as it's a PNG format, that's fine.
Where did you
I
get
know.
PNG?
What was the alpha thing you were talking about?
Don't worry about it because by default it's turned on. There was a little checkbox that says alpha.
Why
That
is
just-
PNG?
Mine is too.
That just means that it draws it opaque.
So then when we open our ping pong project, you
Well,
want it saved with-
Yeah, so what you'll need to do is in your ping pong project, there is an assets.xc assets folder. Click on that guy, and you see the spaceship is in there. There's an app icon in there, which doesn't have anything set right now. So what we're going to do is this. Take your, wherever you have your ball saved, on desktop, ping pong. Okay, so take the ball and drag it into the project like you normally would. Just put it anywhere underneath the ping pong folder. And make sure copy items is set, create groups is set, and finish. Now that places it in your project. There it is, so you should be able to see a preview of it. Once it's in the project, the next thing you want to do is click on the assets folder and just leave that like that. And then without selecting it, click and drag the ball into the assets folder.
So does it need to be in underneath the ping pong? 'Cause
It's better to have it there, just so that it's part of the project. So if something happens to the assets folder or whatever, you can still reference it normally. But in the assets folder, instead of like it'll plop it in the 1x by default. And if you remember, we set the size of our ball to be 30 by 30. So what you want to do is take it from the 1x and move it into the 2x because our actual image is 60 by 60. So what that does is it ensures that we don't have pixelation and it's a nice clear ping pong ball. So you should have in your assets folder, you should have spaceship ball and an empty app icon. All right, so now if we go back to our gamescene.sks file, and select the ball in your scene and set the texture to be, now you notice that ball will show up, set it to ball.
so pixelated.
Everyone got their ping pong ball set as their texture. All right. So next thing we want to do is, now we have that, now we're going to actually start adding some code. So that's the other thing before we get to that point. The gamescene.sks file, you notice you have a scene display tree, kind of like you do with a view controller. You have the view controller, the view, and all that good stuff. Same thing with the scene. So they did a pretty nice job of kind of keeping it somewhat uniform, but having the difference obviously between a game and a regular app. So I think we're ready at this point to go into our code file. So if you go into gamescene.swift, and this is the guy where all the action happens. So the first thing we want to do is actually create our variables that correspond with the different objects that we created in the, kind of like you do with a zip file, only we're going to do this manually. We're going to create a var, our ball, and when we instantiate these, the type of object we're going to make is an SK Sprite node. And we're going to go ahead and instantiate it right away. Now we are going to also need to make variables for our paddle and the other paddle. So we'll create the R paddle. Also, these are all SK Sprite nodes. There's also an SK node, which is like a base class, which has a lot less functionality to it than the Sprite node. Create a U, okay, a them variable. Okay, so we have you and them, and that's all we need for now. Now, in the did move to view, create some white space down here. This again is where we initialize stuff. We need to, this creates like a blank, basically a blank SpriteKit node is kind of like a blank constructor for a view or anything like that. So now we actually have to load it, kind of like you would load a nib from a nib file. We need to actually load this. It's called a child node. So we'll create the ball first, and we're going to call a method called child node, self.child node with name. And the name we can just reference directly from our scene that we created. So we have ball. Make sure these are not capitalized because it does matter. I think I made them all lowercase. Yeah, they're all lowercase. Yeah, okay. So we have ball. This guy's squawking about the. So you have to cast it as an SK sprite node, because a child node can be a number of different types, so you got to typecast it. Them will be the same thing, self.child node with name them. And then the same thing with you. Okay. Now, next thing we want to do is set our ball in motion. So to do that, what we're going to do is we're going to work with the physics body that we applied to it. So back in the scene kit scene, where I wish this was not so painfully slow. Back in here, where we have our physics body stuff, when you set the physics definition, then it creates a physics body around the object. So now we can work with that physics body back in our code. What we're going to do is we're going to apply what's called an impulse. So we can say ball dot physics body dot apply impulse. And an impulse is a core graphics vector object, so it's got a magnitude and a direction. And for that, we can just construct a CG vector. Oops. Yep. There we go. CG vector. And we'll go with the double constructor. So this is something we can kind of experiment with. So this gives it a direction in X and Y and a magnitude. So we'll say, I think I tried 20. 20 is a little high to start with. Once you get a feel for the game, that'll be okay, but we'll start off with 15 for our vector force. Now, Glenn, you asked about the border, and if our ball is just going to like run off the edge and just be gone forever, and it would be. So we're going to need to create a border to stop that, prevent that from happening. So let's say let's border equals SK physics body. So we're going to create a physics body. And this is kind of a goofy, the one we're looking for is edge loop from. So what this means is we're going to create a physics body that's basically like a lasso around a bounding path. So this CG path can be defined as basically a path of like you can create a UI Bezier path. We did that a little bit earlier in the year with some of the stuff we did. It's basically just a path of points. So you can define that a number of ways. You can set it with a number of points, like an array of points, or you can set it with a shape. So in our case, what we're going to do is set it equal to our frame. So this is our bounding shape. That's our border. and we'll do this. We'll say border, so this is a physics body, so it has physics attributes to it. Border.friction will be 0 because we don't want the ball to stick to it. And then we'll say border dot restitution. That's the bounciness or the recoil factor. We'll set that to 1. And then we apply that physics body to the view. Self.physicsBody is going to be equal to border. So basically anything that hits up against this border is going to bounce back. Okay, now let's just run this and see. We'll see what happens to start off with.
I'm gonna ask a dumb question.
Mm-hmm.
What's the object of our game?
The same as Pong. So,
Which is-
do you not remember Pong?
Doesn't it have to go past, so we just created a frame.
Yep.
It'll never go off the screen.
We are not done.
Gotcha. Just making sure.
Yeah.
Oh,
It just
I was
flips across the
scored
screen all over.
there. I was scored.
So now you can see the ball bouncing around. Can't do anything yet. That's coming next. Ooh, that's kind of fun. So what it does is it applies the initial force vector, and then because it's got restitution on both the ball and on the border that we created, it uses the physics body to actually apply the correct vector force. So it's going to bounce around, just keep bouncing off objects.
I got a problem, mine's stuck.
It's on the bottom and it's just going back and forth across the bottom like rolling.
It was doing good and then it hit a corner and it's just going back.
All right, so eventually we'll have like a reset option because that can happen. I mean, under just the right scenario, that can happen. All right, so go ahead and stop it. So, but does everyone have the ball bouncing around like you saw? Okay, good. All right, so we're gonna now we need to actually interact with it because right now it's just the ball bouncing around and nothing else is happening. We don't really have a game yet. So in the update method, so again, the update method is where each time a frame is reloaded or a frame is about ready to be rendered, this is what gets called. So this is our opportunity to change things just before rendering so we can make adjustments. So what we're going to do is before you saw, I think you saw the action file, that guy up there, we're going to code our own action. So we need to have the ability for our opponent, because we're going to be on one side, we'll be the bottom paddle, and then our person we're going against is going to be the top paddle. So when the update is about to occur, we're going to call them.run, and this is going to run an action. And the action that's going to run is, this is a static SK action dot move to, and that is fine. The parameters are x and duration. That's all we really need because we're just going to move back and forth in the x. The paddle doesn't move in the y. So the x is going to be the ball. So this is going to be our opponent reacting to movement of the ball. Ball.position.x. And duration is a time interval in milliseconds, or actually in seconds. So what we want to do with this is we want to set this fairly high because otherwise they're going to be unbeatable. So otherwise, I mean, if this was set to like 0 or even like 1/10 of a second, their movements are going to mask the ball perfectly, and we're never going to be able to score on them. So what this does is it builds in like a delay factor. So the ball bounces off our paddle or off the wall, and then they take like a 1 second to react to it so that we can at least score on them. So time interval will be 1.0. We'll start with that. And then as we get better, then we can go ahead and bump that down. So let's go ahead and run that, make sure that that's reacting the way we want it to. So we should see the opponent's paddle moving around. Yeah, so now they're going to whoop up on us because we can't do anything. We're hopeless. We're like a turtle on its shell. Oh, there we go. Got one in there. Yeah.
Oh yeah, we got 2 of them.
So anyway, that's that. Now we need to be able to do our own. We need to fight back. So now we're going to code in some touch events. So I'll start off with touches began. So this is almost identical to a UI view touches began or a UI view controller touches began delegate. You have a set of touches. So we're going to basically work with it the same way. What we'll do is we'll get the first touch, because this is basically a single finger game. So we're just going to, we'll just assume that like the index finger is what they're playing with primarily, and if another finger happens to make contact, that's just incidental. So we'll say touch equals touches dot first. So that's going to be the first touch in the set. I think, oddly enough, I believe that iOS supports up to like 7 simultaneous touches. So you have to have like all the fingers in one hand and then 2 from the next, but I think that's what it supports. Now we're going to get the location of that event. Location equals touch dot location. And in the node is just us. Now we are going to react to that. So now we say u, which is our paddle, dot run. So basically, actually I'll borrow this code here and copy it and paste it here because it's going to be the same action. Only we're going to give ourselves a big advantage here. We're going to say 0.2 will be our reaction time. So 0.2 of a second.
We have to change it to you instead of that.
Yeah, thank you. And then if you run it again, and then you tap on a spot where you think the ball is going to go, oh, I missed. I suck at this way. Part of the problem is we don't have a touches moved event, which we have to add. So you just kind of have to anticipate where you think it's going to end up.
Well, and it doesn't move very fast when you click.
Well, that is in part due to the fact it's running in the simulator. Because like I say, on a device, it's much more responsive. All right, so we have some minimal defenses set up now. But now that we'll want to actually, so the way the game's actually played is you move your finger around on the screen back and forth, and it moves with movement of the finger. So all we have right now is the ability to tap and have it move. So now we'll go ahead and code in the touches moved. And then we can do the same thing in there. Basically, we can copy the code from up here. paste it down in the touches moved.
The whole thing.
Yeah, because you'll need to get the touch object and location and all that. And we'll give it 0.2 of a second duration. You can get, if you want to, you can bump that down to 1/10. Might be a little less frustrating. And now you should be able to move it around and actually have it move with your movement of the mouse. I still suck at it. It's a little bit weird though. There we go. It's really touchy.
It's got
No,
some-
mine's not moving at all.
Mine's moving, but it's got some sporadic.
Yeah, it's got some glitchy stuff.
Mine's not.
I think that might be graphics. I think the glitchy movement could be graphics acceleration because I don't really notice that so much.
Mine's not moving though with my mouse at all.
All right, so let's have a look and see. So do you have the, does your code look like this?
That's why, you gotta click and then,
Oh yeah, you have to tap on it.
So what's the difference?
click and then you.
Because you don't actually, it doesn't register a movement until you make contact. It's not like a website. You have to actually, you don't have a hover, you have to
I
actually.
saw your mouse moving, so
She was hoping ESP was
I thought it was gonna sense my mouse. Or
Yeah.
something.
Sense your retina position in your eyes. All right. Okay, so I don't want to go a whole lot long with this because I did say I'd give you most of the time for lab stuff. So the other thing we can do, we don't have a means of checking to see score yet. So we should probably set up some scoring method.
She broke it.
You broke it. What happened?
My paddle ran off the side of the screen and now it's just, both paddles are halfway off the screen and it's just going up and down.
Oh, we'll just stop it. Well,
I don't know. Oh, we-
I figured I keep track of all underneath my paddle and just keep it going back and forth along the bottom.
let's set up real quickly do a scoring mechanism here. For our score, I'm going to make my score an array of integers. So if you ever make like a more than 2-person game of Pong, and then another thing I'm going to do is create a function here that allows to restart the game. Let's just create a func called start game. And we'll set our score to be 0 and 0. So this array is just simply going to represent our score and our opponent's score. And then let's also make a function. Let's make a function called add score. I love the way it just pops up a suggestion. Hey, you want a spaceship here? Not really. Okay, so let's pass in a parameter called who to add. This will be an SK sprite node. First thing we'll do when we add a score is we'll reposition the ball. That's kind of how Pong works, if I remember right. We'll set the ball position to be a CG point at 0, 0 right in the center of the screen. So that'll fix problems with the ball getting stuck wedged behind the paddle. What does it not? Oh, yeah, I don't have parameters. X and Y. and then we'll reset the. Let's bless you. Let's do this. Let's just run it without doing anything else. Well, no, don't run it yet, because I haven't actually determined the means of adding a score.
Can you go up to the top first?
In our did move to view, let's go ahead and call start game right away. And All right, so now in order to figure out how to add points, we need to go down in our update down here and see if the ball is past one of the paddles. So what we can do down here is say if ball dot position dot y is less than or equal to u dot position. Let's see now for our position. Let's this is going to be at the top of the surface of our paddle. So we need to subtract the width of the paddle and then maybe give ourselves a cushion past that just to be safe. So we'll say that. We'll try that out and see how it works. Position.y. If it is, we'll add score for our opponent. So we'll pass in them to our little add score method. And then we can say else if ball.position.y is greater than or equal to them.position.y plus 50. Add score, passing in us. And then in the add score, we can just say, do some logic to see who's getting passed in. If who to add equals u, score 0, first element in our array, that's us. We add 1 to it. Else it's only going to be one other option, score 1 plus equals 1. And then for right now, eventually we'll add labels to this and all that. I gotta add the question mark. But for right now, we can just do a print score. And then the other thing we'll want to do is once a score has been made, we should set, let's see, we want to set ball, we'll leave that as is. But we should probably, we'll just leave that as is. Let's do this. So if we score, so if you score, I think if I remember right in Pong, it starts the ball over heading towards your opponent. So basically, it like gives you get like an added little bonus for scoring on your opponent. So let's in here, let's say ball dot physics body. Oops. Ball dot, and that's let's do this. Ball dot position equals CG point. We'll set it back in the center. X0, Y0. And then we'll say ball. Let's copy this code up here. Ball.physics body, apply impulse. And then the same thing, we can do the same thing for if they score. Copy that code that we just put in there. Put it in the else block. Only the impulse is going to be negative 15 for both values, and that will shoot the ball towards us. And we can take the ball.position out of the if-else because we have it up above it. So we don't need it down here. There. Now let's run this. And then you'll probably notice something interesting happen. So
Wow.
kind of gets a little bit hairy there, doesn't it? All right, the reason why is because, and you can stop it before it gets too insane. These impulses, what happens is they're additive. So if it already has an impulse and then you apply another impulse, basically it's like multiplying it. So each time you score, that physics vector, that velocity vector is going to increase. So what we'll want to do is we'll want to clear that out when a score is added, and then restart the ball. So we can say ball dot physics body dot velocity. So we'll just stop it.
Mine's like infinitely broke.
Uh-oh. Yeah, it might have got out of hand.
No, like it never did any of that.
Yeah.
I just went up and down.
All right. So where are you at?
I'm in the add score. So what I did was I added this line right below the ball dot position. I set physics body dot velocity to be 0. CG vector of 0, 0. That will stop the ball and remove the vector, the force vector from it. And then you can then it'll reapply it.
That's a double, right?
Yeah. Yeah, so now you should see it restart and head towards your opponent right away. If you let it get past you, you should see it come back at you then. All right, so that should be good for tonight. You should see the score. Right now it's not formatted real nice. It shows the optional because we need to make it unwrap it, but you can see what the scores are. So the first value is your score, second value is the opponent's score. So what we'll do is we'll next week is we'll kind of finish this off by adding labels to show the score, and then instead of having like where it restarts in here where we do the add score, when we do the add score, we set the physics body to this hard-coded, 15, 15, negative 15. We'll randomize this. We'll still have it be heading towards the opponent or heading towards us depending on who scored, but we'll randomize the physics vector. So it might start off slow or it might start off fast. And yeah, we'll add the labels and then we'll allow the ability to stop once the game is complete. Let's say we'll go up to like 15 or something like that.
Ping pong is 21.
Is it? Yeah, I guess you're right. All right, 21 then.
Kristen's age.
Well, my age minus about 4.
It's my golden birthday this month. I'll be 29.
Oh wow, 29. Yeah, I saw that 29 disappeared in the rearview mirror a while back.
I'll be 19 in like a month.
19. Are you shaving yet?
Yeah, I did like last week after like 3 weeks.
All right, so now we're getting to that part of the class. So I'm going to go ahead and stop recording.